Hi everyone, good afternoon, this is István. Today I will talk about AI economics, as you can see. I guess some of you have some project idea to implement with an AI, and you would like to know how much would it cost. Unfortunately, this is what I can't answer today. You will see soon why. Is it better now? Okay. This is the first time with the mic, sorry. So how much would it cost? I don't know. We will see. Why not? Because it's a pretty complex topic. But I will talk about the pricings of different large language models, costs of the infrastructure that is needed to run these agents, models, whatever. And also at the end, I will give you some recommendations how to start a project that uses AI under the hood. So the cost of an AI project. Why I can't answer this? Because it's pretty complex. AI projects can cost from a few $100s to even millions of US dollars, or actually all the money in the world. There are many factors that influence this cost. For example, if you are working in a medical domain, then you have to spend a lot of money on testing and validation. If you are working on an agentic AI, then you have to spend many hours on integrating different APIs or even building APIs that are not existing yet. Also, for example, if you need some model development or use one, there is a huge difference between the building and the usage. So each factor can move on a pretty wide range, and each of them could take a whole talk. So I will just focus on the first one, the model development and usage. There is a nice article on LinkedIn which compares these both scenarios when you want to build a model or you are using one. For example, Meta built the Llama model in 2023, and only the infrastructure that is used for training costed around $4 million US, not involving the development time, not involving the data preprocessing, the storage, and so on and so forth. Meanwhile, if you imagine a company that would like to analyze all the annual and quarter reports of all public companies in the whole world, and also you would do some sentiment analysis on the transcripts, then it would still cost only $14K a year. Compared to the $4 million, that's a huge difference. And this analysis can run on a model that is trained by Facebook for $4 million. So actually, usually you don't need to build your own model. Sometimes this is the case, but usually you don't. This is why I will just focus on the model prices, not building them. When we are talking about large language models, there are many companies that are building their own models. But before we could compare and analyze these models, we have to understand how they are working. Just from a bird's view, of course. But all of these models are getting the input and split it into smaller chunks. Then these chunks as a sequence will be analyzed, and the model will try to predict the next most likely chunk. And we will do this until it thinks the whole evaluation is done, or processing is done. These chunks are called tokens. The tokens can be words, word stems, subwords, or even just characters in the whole text. If we are talking about a multimodal model like Gemini, then it can be a pixel on a picture, or a sound in a video, or a sound file. All these models are identifying these tokens. All the models are identifying the tokens differently, which means that, for example, Gemini or OpenAI will identify different tokens in the input text. This is called tokenization, but usually the providers will give you an option to check how many tokens you have the input. So, for example, you can send your file to an API, or you can paste it into a website, and it will just tell you how many tokens are there. It is pretty important because the pricing is based on the tokens. So only the tokens affect the price, which means the complexity, the domain doesn't matter. If you just want to read the characters in a whole book, then it will be much more expensive than doing some complex math calculation. Only the tokens. Also, the speed is defined by these tokens. Now, as we know how we compare the prices of these tokens, because we just need to know how many tokens we have and see the pricing of the website, the token, we have this nice website, the artificialanalysis.ai, which actually lists most of the models where you can compare them based on different metrics like the maximum input size, the speed, the price, or even the intelligence. So if you want to compare these websites, just go there. But I have done this last week and I made some screenshot. Can you see it? This is the so-called leaderboard on the website, which lists all the models, and you can order the list by different metrics. Here they are ordered by price. So you can see at the top the most expensive, at least last week this was the most expensive model, the O3 Pro. Here you have to pay $20 for the input. And I will go into the details because there are two interesting points on this picture. First, there are different prices for the input and the output. So if you want to read the book and summarize it with the AI, then you have to focus on the input price. If you want the AI to generate a whole book, then you have to focus on the output price. Usually the output price is more expensive, let's say 4 or 5 times more expensive than the input. But this is not always the case. This is not the rule. You can see at the bottom there is a Llama model which costs the same. Yeah, that's this is one. The other part is the price is based on 1 million token, so it is not just one. It doesn't mean that you have to pay $20 to understand one token. But what is 1 million token? Because that's a lot. How can you measure it? They say that 1 million token is around all the Harry Potter books together. Or if we are talking about sound, then it can be 200 podcast episodes, which means that in small scale, when you just try out these models, it's not expensive at all. But as soon as you scale, the price can skyrocket. Yeah, let's see the bottom of the same list. This is still ordered by price, and if you go at the bottom, then you can find some models which cost only a few cents for the same 1 million token. It is 1,000 times difference. It's huge. But still, if you look at the bottom, these models are usually much slower, less intelligent, or can handle a much smaller session or token count within one session. Still, they have the use case. So for example, if you look at the bottom, the Gemma 3M by Google, it is pretty good to running on a low resource environment. So if you want to run the model on a mobile or an old desktop, laptop, which is not connecting to the internet, then it can be pretty useful as a simple chatbot. Yeah. On the same side, there are nice charts. You can check it out, which one is good at speed or intelligence, or even the price, but I would like to highlight the chart at the bottom. This shows the evolution of the models, so how the intelligence has evolved in the last 2 years, and as you can see, it is at least tripled in 2 or 3 years. So it is really at the beginning of this evolution. Yeah. So I think everyone knows everything. Now we know the pricing, we know how to get the tokens, we know where to compare these websites, and we are good to go. But unfortunately, this is not the case, because there is another important aspect I didn't mention before, that there are different kinds of models. There are open source or source available models, and there are proprietary models, which affects that where you can deploy the model. You can deploy it on your own infrastructure, or is it deployed and you have to pay somebody because it's deployed there. And this can affect the cost as well. There are 3 different options. I will talk about them on the upcoming slides. The model developer managed, it's a good example, the OpenAI's ChatGPT or O4, O5, which is pretty new. In this case, the model developer, I mean OpenAI, has built up the infrastructure, deployed the model there, and you can communicate with the model through an API. In this case, you have to pay on a token basis, and you can get different discounts. For example, a batch discount. If your problem is not time sensitive and you can wait for, let's say, 1 day before you get the answer, then you can get a 50% discount. Or if you send multiple times the same prompt, then it won't re-evaluate the prompt again, but it will send back the first response several times within a time frame, and this won't. For this, they will give you a 50% discount again. The next option is the cloud service provider managed, which is pretty close to the previous one, but here we have two parties. First, the model developer, let's say Facebook, and we have the cloud provider, let's say Microsoft Azure, and they will just deploy the Llama model on their own infrastructure, and then you can communicate with that model with an API, again, just before, but now the model developer and the hosting service is not the same company. Here you can get some extra features, like advanced monitoring, or some security levels around the model. And also, you can get different prices based on the region, based on the model, based on the provider, the model provider as well, or the performance tier that you are using. So if you are okay with the slower response, then you might pay less. And that is really important that these cloud service providers are supporting multiple models. So actually, you can choose. You are not logged into the provider's model, like on OpenAI, you can use only OpenAI's model, but in this case, you can use Meta, DeepSeek, whatever they support. So there is a bigger independence or flexibility on this. Then the self-managed, which gives you the biggest independence, but it is pretty expensive at the beginnings. It means that you get an infrastructure by renting one from AWS or by buying a lot of GPUs and build your own computer, and then you can just set up you can deploy the model to your infrastructure. In this case, you are not paying on a token basis because you are owning the infrastructure and you are paying for that. When you are renting, then you are paying on an hourly basis. When you are buying and building your own infrastructure, then of course you are paying at the shop when you build. And you have to pay the electricity bill as well, which will be pretty high. In both cases, you have to have a team who is maintaining this infrastructure, because of course it is self-managed, which can cost a lot, especially at the beginning. But you can deploy any model on your system. Comparing these three options, the model developer managed is the easiest for starting. Actually, it is the cheapest at the beginnings, but it is easy to get logged into a vendor because you cannot pick other models, and also it can be costly as you scale up. The cloud service provider, yes, and the model developer managed, this is why it's a good choice for the beginning to test your idea. But the cloud service provider managed is a bit more complicated. Here you can pick from different models, so you have a bigger flexibility, but since you get extra features and extra services, sometimes you have to pay more. It is better for the next step or a bit bigger companies, I think, or also if you already have an infrastructure at a cloud service provider. And the next one, the self-managed, I think that's the best when you are in an enterprise and you already have knowledge in-house how to maintain these infrastructures. It will give you the biggest independence, and it can be the cheapest in the long run, but at the beginning it needs much bigger investment because you have to build or buy the whole infrastructure. So after getting familiar or got familiar with these different approaches, I would like to show you a case study from Dataiku. On the website or in the article you can find more examples as well, but I will just show you one case study. Let's imagine a company-wide knowledge assistant which is used to analyze multiple documents or just find some relevant information in hundreds of pages, which is pretty hard for a human colleague, but the AI is perfect for this. In this case, I will distinguish a low usage scenario, or they distinguish a low usage scenario and a high usage scenario. In the low usage, the sessions are smaller, meaning, I don't know, you send smaller files, or you just have less sessions a day, or less users are using this assistant. In the high usage scenario, of course, there are more users or bigger sessions. You can see at the bottom the tokens that they are using for the calculation. And using the GPT-4o Mini, which is a relatively cheap model, but it's perfect for this use case, you can find the total cost is around $1,300 for the usage scenario per year, or $26,000 for a year in a high usage scenario. There is a huge difference, of course. Doing the same assistant in a self-managed version. We can use the Llama model from Facebook. It is source available, so we can set it up in our own infrastructure or rented infrastructure, and it can run on a relatively small AWS instance. You can see I use this 2x large. Here, the hourly cost in a 1 year commitment is almost $1, so totally it will cost around 8,000 or a bit more than $8,000 a year. Meanwhile, with the longer contract, 3 year commitment, it will cost around 6,000, a bit less than $6,000. If we compare these two, you can see that for a smaller usage, the low usage scenario, the 4.0 mini will be the best. But as you scale, the self-managed can be much better. You can reduce the cost around 80%, which is a lot. But still, you have to have a maintenance team, and you have to set up the whole software infrastructure around it. So again, it will be just better on the long run. But on the long run, it's much better. Yeah. Then this is what I wanted to talk about the prices, and now see or get some recommendations on how to start. First, just validate the idea. So there you have seen a lot of prices, huge numbers, but no, when you just have an idea, just start with any model that you wish. Use, for example, Lovable or any low-code tool, and just set up or mock up something, and after, and of course, start monitoring from day zero, because it will be pretty useful in the next steps. But don't overthink, just do your project, and then later you can refine it. As a second step, as you start to scale, you can reduce the cost, because if you don't pay attention to this, they will skyrocket soon. Here you have more options, for example, the prompt and context engineering. There are a lot of articles on the internet about this, but with proper prompt engineering, you can reduce the token count, the overall token count, both on input and output side, and also you can keep or maintain the information amount in these sessions. Other than the prompt and context engineering, there is this problem decomposition, which means that you step back, think through your whole application, and split it up into subtasks. And I'm sure that several subtasks can be done with simple logic, with simple coding. You don't need a huge general AI to do everything. You will find just some subtasks that are more specific, and then you will be able to find the model which is more specific and smaller to this subtask. It will perform well, it will be cheaper, it will be faster, and it will be better in all the aspects. Actually, ChatGPT works the same. They have different models for different use cases, like text generation, GPT, DALL-E for image generation, Sora for video generation. But you have one prompt, and it will decide under the hood which one to use. There is this website, huggingface.co. It has tons, actually more than 1 million. I think it's already 2 million models, which is more specific. And you can just pick to your problem. For example, there are financial related models, there are biomedical models, there are teaching related models, and whatever you can imagine. So if you are looking for specific models, just go there. You can also rent infrastructure on Hugging Face, and you can run the models on it by yourself. After reducing the cost, you also have to prepare for the changes, because as we have seen, the field is changing and evolving rapidly. There are always new models which are better, faster, cheaper, whatever. You have to prepare for this, and there are already architectural patterns like the LLM mesh from Dataiku, which helps you to how to get independent from the model or how to make it more replaceable. And also you have to proactively try and check the new models, because, as I said, there are always a new one. And you can always refine your models and the workflow. So the takeaways from this last 20 minutes. First, just validate the idea, don't overthink, just start somehow. Then you can break down and find more specific models for your problems or subtasks. Then you have to prepare for the changes. This is really important, I think. And of course, use experts, because the field is already full of developers who have some experience in this topic.